Okay, good morning. And we today started our first practical lessons by our disciplines. Now I share our distance course. Okay, we could share our disciplines in the height part. It is operational logistic management in supply chain, and we find our practical lessons number 1. It is information about schedules, about how to connect it to our lessons, our testing models, lecture materials, and we find practical. Practical lessons number 1. Here where you could see red positions, it is when you could connect it your task when it finished or send me by email, send me by telegram or other message. Okay, and the last link, it's about materials. Oh, sorry. About materials for today. And our task for today, now I try to do it adding maybe or maybe more. Mhm. Oh, try. Okay, so you could use any electronic documents or paper documents if each more suits for you. And please write in your document or in your paper the name of our topics today, yes, of our practical lessons number 1. It is choosing a cargo delivery scheme. First time you could remember maybe because in the first semester we did the same task about choose which kind of transport is better for our delivery. This first task by our new disciplines is the same. We also choose which type of transport is better. It could be railway transport or car transport, but it is another type of calculations, and we try to do it. So we see the materials about this our first task and write please the topic. Okay, Jana, you have a questions? Your microphone is on. Oh, okay. Yes. Okay, when you write then topic of our task number 1, it is the same task, economic justification for choosing a cargo delivery scheme. And this first task contain free task. It's the same as in another disciplines. We choose and calculated some economic and technical positions for railway transport. We'll do it today. The next practical lessons, we calculated the same positions but for cargo transport and choose as task 1.3, we choose type of transport by special method and find what is better for us for delivery our cargo. Okay, when you write the topic and your name and surname on your paper or in your document, saved this document if you used electronic versions. So, according to the initial data, it is table 1.1. We used this table with information about different positions for our imprint and task options for our variants. So we used this table later. It is necessary to analyze the cargo delivery scheme. The carrier can use both main rail transport and road transport, and we need to don't calculate it how to connect this transport. We choose one of them. So we have such type of task and find it. In the first case, the cargo is loaded from manufacturer into feeding and picking hub wagons in a shunting manner along the access track. So we find such manufacturer, and this company has special shunting road, shunting track, and we could use it to deliver our cargo to the railway station. And after it, we use different types of transport. From the station of departure to the station of destination, the cargo is transported as part of consolidated trains. So it is not very big part of cargo, it is a little part of cargo, and we couldn't use this part of cargo for one train because it is very little part. And we also used consolidated trains, and this part of cargo will be connected to the big trains with different types of cargo from different companies. And for delivery maybe in different ways by different track later. At the destination station, the cargo is also delivered to the recipient along the access track. So we used such technology of delivery from door to door, but from one manufacturer to another manufacturer. We used public railway transport, and we use this short track, short shunting track from one manufacturer to railway station of departure, and from railway station of destination to manufacturer of cargo delivery manufacturer, so destination manufacturing. Okay, in the second case, we will do on the next practical lessons. The delivery of the cargo is carried out by cars from the manufacturer to the recipients, and we use the same technology, delivery from door to door, but we used car transport. So it is only one difference. After completing the calculation, you should compare the modes of transport according to the basic requirement listed below and give recommendation on choosing the best options for cargo delivery. So, basic user requirements for transport. Reliability of transportation, minimum delivery time is one of principal logistics. We discussed it at our lecture. Regulatory of cargo delivery, guaranteed timelines of cargo delivery. It is transportation safety, of course, yes, because every transport need to prepare for this type of activity. Ensuring the safety of cargo during delivery. It is convenient in accepting and transferring goods, availability of additional service, no, and other positions you could see on them now and maybe remember. And I think we already discussed it, but I think we need 1 minute to see all these basic positions, please, and start it to our calculation today. Okay, I think you have time to see these all positions, and we go to our task. So we need to see the information, initial data for problem one for our task number one. We have cargo name. It is different types of cargo for every variance. It could be gravel, sand, slag, slag, and other types of. Sometimes it's repeated for different variants. We have annual volume of transportation, 1,000 tons. It's in 1 year. We have very often we have this information by big periods of time. For example, 1 year. We have price of 1 ton of cargo, distance for delivery, yeah, distance for delivery by railway transport, and later we used for car transport. Wagon type. For railway transport, we have technical norm for loading in one wagon. So if we have, for example, gondola car, we used 65 tons by one wagon. If we have platform, for example, we use just 45 tons on one wagons. No, and as information, we used it now during our calculation. I think it will be better. Car branch, it's we used for railway transport, we will use later. And duration of car, how many hours during one day works our car company for delivery, will use it later. Okay, and our first task, it's 1.1, which we need to do today. It's the rail freight transportation option. So you could write this topic of our short task, part of our first task, rail freight transportation options. And we started not from first formula, we started from the last formula and come to the first formula to find the main delivery time by rail transport. So, okay, I think you already write this name of task and we go to the last our formula. Here we use this information from appendix and we need to find, okay, no, not from the last, we need to find, 1 minute, our 1.4 formulas we could use to each. This formula is about average daily number of cars supplied to excess checks, and after it we find time parameters, and after it we go to the money parameters. So, sorry, not from the last formula. Formula 1.4 will be the first for calculated now. So we write in our paper or our electronic document that U, it is average daily number of cars supplied to the excess tracks. We use the shunting tracks from our manufacturer to station of departure and used how many wagons we deliver every day from this manufacturer to our railway station that's located near a manufacturer. So we write U is equal to, and in the higher part of our formula, we use such parameter as Q, big Q. It is annual volume of transportation in tons. We need to use these parameters. I open now our information for our variance and we could find these parameters. So we need Q, big Q. Find it our table 1.1. Okay, it is our 1, 2, 3. Third line from up of our table and find by your variant, please. I remember that you choose your variants by the list of your group. For example, if you are first at your list at your group, you have first variants. For example, if you are second in your groups, you have second variants. Okay, if you have first variance, so you write in up of our formula 47.5, but remember that we need to use this parameter in tons, and now we could see that it is in 1,000 tons. So we could write already 47,050, 500 for example. Or you could write 47.5 and multiply by 10 in third square. Okay. For the variance as volume of transportation, please find it. Okay. I think we find these parameters and come back to our formula 1.4. Okay, and in the near down part of our formula, let us say it is 365 multiplied by such parameters as p with index stage. What it means? What does it mean? It's technical norm of loading the wagon. It is ton by 1 wagons. Okay, we find this information in our table 1.1. Okay, find it. And it is the next parameters after wagon type. It is which is what it line? It 1, 2, 3, 4, 5, 6, 7. 7 line of our table. And we could see if you have first variant, it is 65 tons by one wagon. We used the same position. If you, for example, third variance, it is 45. Yes, if you, for example, H variance, it is 48 tons by one wagon. Okay, and we could calculate it. We find all parameters. Sorry, I saved our screenshot. Oh, sorry, and come back to our materials. Okay, I open our formula 1.1, 1.4, sorry. The result we have in wagons. How many wagons we got delivery from this shunting track to our railway station? We could find, for example, 0.5 wagons or, for example, 1.5 wagons in different variants. We could have different types of the result. But we need one wagons, two wagons, three wagons. Yes, we need such positions. So we rounded it up in upper part. So, for example, if you have 0.5, it is equal one wagon. Yes, if we have, for example, 1.5, we need two wagons for delivery by these tracks. Okay. To round up the number of wagons. Okay, our next formula is formula 1.3, and we need to calculate the time. We need to calculate t, big T with index sh. Under the formula 1.1, we have this information that big T with index sh, it is duration of shunting work of excess track maintenance in hours. So we could find this duration of shunting work. Okay, in our numerator, it's 1.3 our formula. Big T with index sh is equal to, we use the result of our previous calculation, how many we have, yes, how many wagons we have in one day, and multiplied by the time. It is little t with the same index as h. What does it mean? We read under our formula. It is duration of shunting work per one wagon in hours, and the value of which, depending on the average daily turnover, is found for the excess tracks of the sender and consignee of the cargo according to the formulas of Appendix A. So we use find these parameters in our appendix. Go to this information and find what we need from table 1.1 for this finding. Okay, it is table A.1. It is duration of shunting work of maintenance of the excess track in hours. So we have the result in hours, and we could see that it is little t with index sh in the second columns, yes? But in the first columns, we need to find the information about car turnover of the excess track in wagons. So how many wagons we deliver it every day from manufacturer to our railway station? We find this information in table 1.1 and find which time we need for these operations. And after it, we need to find the information in table 1.1, how many wagons we delivered from railway station to manufacturer, and calculated this time, because very often do we use different tracks for delivery from station and on the station. So we need to calculate it twice. Sometimes it could be the same position, but it could be different. So we need such parameters as how many wagons we delivered and how long is this distance of this shunting track. So we come back to our table 1.1 and after come back to this table. Okay, we need these parameters by both part of our rods. So we have, I open this variant so you could see this information. First, what we need, it is carrying turnover of the excess track by delivery. By delivery from manufacturer to our railway station. We need to find how many wagons we need. It is the line of our tables. It is first, second, third, fourth, five, six, seven, H line of our table. It's a parameter O with a strich and T. O, strich and T. And we find how many wagons. For example, for first variance, it is 15 wagons. For second variance, it is 25. For third variance, 30 wagons. Find, please, your number of wagons and write somewhere on your calculation places on your paper or in your electronic documents. Okay, and we need the last parameter, the next parameters, it is distance. Distance along the delivery, by delivery in both directions. Okay. Why we used this delivery in both directions now? Because we could go use the locomotive of station or own locomotive, and we need to deliver this part of wagons from manufacturer to station, and our locomotive could be go away. Or maybe no, if we used, for example, locomotive of station, so it's free go to the manufacturer, give these wagons, and come back to the station. So we used both delivery distance. Okay, for example, if it is first variant, we use 15 wagons and 5.6 kilometers. If second variant, 25 wagons and 4.8 kilometers. Let's find your information. It is from manufacturer to railway station. And in another side, we used the next information with these two parts, O with 2 strich T and L with 2 strich OT. So, for example, if you have first variance, also write in some place on your documents that we have 24 wagons and 4 kilometers. If you have second variant, 36 wagons and 3.6 kilometers. Please find this information for you. Mhm. Okay, and we come back to our table in Appendix A. Oh, sorry. Yes. Okay, if we, for example, have by first part of our delivery from manufacturer to railway station, 25 wagons. As example, yes, we go to our first columns, find in which line is located our part of wagons. For example, 25 wagons. It is second line of our first columns and go to find this time in second columns. For example, if we have 25 wagons, little t with index sh is equal to 0.127 plus 0.0731 multiplied by our distance for delivery with one strich. So we find this information and calculate it now. The result will be in hours. And we used, let us two or three points after point. Okay, please calculate it. And after it, you could calculate it the same position, but for delivery from railway station to manufacturer. Okay. For example, in the second part, we have 36 wagons as example. Yes, we find that it is third line and calculate it by another formula and use another distance, L with 2 strich. Okay. Calculate it, please. The result will be in hours, and we could leave 2 points after comma. It's enough. It is time. Calculate it, please. If you have some question, please ask it. Maybe you couldn't find something. He follows. Okay, calculate it. Mhm. Okay, we have less than 1 minute and need to do break. Please, we stop and come back to this table later. And I wait you after 10 minutes, okay? I stopped our sharing. And we will come back at 22, okay, 22, 25 minutes past 10, okay? I will wait you by the same
Okay.
link. Yes, thank you.
Okay.
Thank you.